Hello everyone! Welcome to Arduino with PictoBlox. In this video, we are going to program an Arduino Uno board using PictoBlox. Most of you must be familiar with Arduino and with programming. And you know how tedious it can be to control a hardware using a program. This is where Scratch comes into the picture. It is a graphical programming language developed by MIT Media Lab. It lets you code using graphical elements known as blocks instead of typing each instruction. This makes programming fun, interactive, and eliminates the need to worry about syntax. PictoBlox, the programming software that we are going to use today, is based on Scratch 3.0. You can make games, animations, and do lots of other cool stuff with it, like controlling prototyping boards such as Arduino Uno, Mega, ESP32, and Evive. Let's have a quick look at the user interface. There's a purple colored menu bar at the top with several buttons. The white space on the right is called the stage, the area where the sprite performs action according to your code. A sprite is nothing but an object or a character which performs different actions in the project. The bear standing in the stage is a sprite. On the left is the block palette. It consists of different palettes under the code tab. Each palette consists of blocks which are used for writing scripts in the scripting area. Scripts are the program that we write. In this video, we are going to write a script for controlling the LED connected to Arduino Uno's digital pin 30. For controlling Uno, we need to first connect it to PictoBlox. First, connect it to your computer via a USB cable. Then click on the board button in the toolbar and select its name from the drop-down menu. Next, click on the connect button and select the appropriate port. In doing so, you'll notice new palettes below the My Blocks palettes. You can control Uno using the blocks from the Arduino Uno palette. To control the LED connected to pin 13, we are going to use the Set Digital Pin Output block. We need two such blocks to make the LED blink. So, duplicate it by right-clicking on it and set the output in this block to low. Now, to control the speed of blinking, we are going to use the wait block. Go to the control palette and drag and drop one below each Set Digital Pin Output block. Now let's stack all the blocks together. Observe that this script will run only once. In other words, the LED will turn on, wait for a second, and then turn off. To make the process continuous, we'll use the forever block from the control palette. It will run the script till the time you stop the script. To start any script, a head block is necessary. Therefore, drag and drop when Arduino Uno starts up block above the script. Now, we need to upload it to the board. For that, switch to upload mode by toggling this button. The stage is replaced by an editor window with the equivalent C++ program for the script. To upload the code, click on the upload code button. Once the upload is complete, the LED will start blinking. Before we call it a day, here's a small task for you. Try increasing the blinking speed of the LED. The hint lies in the wait block. That's all for now. In the next video, we'll find out how to give senses to our projects. If you have any question regarding this video, let us know in the comment section below. And if you like this video, don't forget to give it a thumbs up. I'll see you in the next video. Bye for now.